A very warm welcome to Computex 2021 in Taiwan. I want to greet all of our customers, all of our partners, all of our friends, and everybody who, just like I am, everybody who is excited about the prospects of technology and about the impact which technology is going to have on the world. And when I think about the future of the world, I see this massive opportunity of probably 50 billion intelligent and securely connected devices in the year 2025. And that goes hand in hand with a significant change in what technology is going to do. In the past, technology has become very fast and very positive in terms of responsiveness. I hit a button and the machine does what I want it to do. However, my future vision of technology for us as people is very different. It is about a world where technology is actually automated, is actually advancing and anticipating what we want. It is a world where simple tasks become automatic and complex tasks are being foreseen by the machines we are interacting with. And all of that is going to be enabled by what we call the intelligent and secure edge, which will be complementing in a perfect way the cloud computing systems which are in place already by today. And here is the opportunity for society, realizing, dreaming, and getting at work for this world of 50 billion secure and smart connected devices is a challenging and complex task. I'd actually go that far and say it is a task which cannot be accomplished by any company alone. And for that reason, I am actually very, very proud that today, for my keynote, I'm showing up here in very close partnership and very close collaboration with a number of very proud and strong technology leadership companies, such as Advantech, Amazon Web Services, BMW, Garmin, Microsoft, Samsung, and TSMC. Now, for my keynote, through the next 60 minutes, I will be also working with two of our colleagues from NXP. So Shelly from Dyke from our automotive business and Martino from our intelligent edge business is going to be with me on stage today to give you fantastic and what I personally think is exciting examples of how we bring the power of the edge into life. We can all feel and experience the acceleration of that digital transformation to the edge in our everyday lives. It is all about the difference how we pay, how we consume, how we move. All of these everyday activities are facilitated now in a very different way through edge applications. And that is mirroring back also in the performance and in the speed of our business. So on behalf of the entire NXP team, I'm very proud to share with you again that we were included in the S&P 500 index, which marks a major milestone in the history of NXP. And with that, it goes without saying that we are also proud that we just shared with Wall Street that the Q1 of calendar year 2021 marked another record level in our revenue achievement. Now, that acceleration of the business is also going hand in hand, not only for NXP, but for the entire industry, to an unprecedented situation when it comes to the shortage of chip supplies. Demand for silicon, especially for silicon for the intelligent edge, has accelerated at an unprecedented pace since somewhere in late Q3, early Q4 last year. And clearly, we all see it in the newspapers, in the headlines every single day, many sectors are now suffering from very tight wafer supply. And I can assure you that everybody within the NXP team, with our partners, is busy 24/7 to optimize the supply to our customers, to the industries we are so proud to serve. Now, next to all of that hard work, there is another element which I believe is truly important to ease that situation going forward, and that is the fast pace towards innovation. The faster we can move to smaller nodes, to more modern technologies, the better is going to be the availability of the required capacity. And I'm actually very proud to share here and today that we are announcing today, together with TSMC, 2 new flagship products which are ready for mass production, which very much match that pattern of innovation to help the capacity situation. And I'm talking about 2 16-nanometer FinFET processors, which are first of their kind in the industry. The one is for radar processing applications in the car, the other one for intelligent gateways in the car. So 2 16-nanometer processors running in the factories of TSMC, ready for mass production, are being launched with this meeting today. And my colleague Shelly will give you more details later during the keynote. At this point, it is good to zoom out a little bit more and take a bigger perspective on where are we in the evolution of the semiconductor market. The semiconductor market growth has always been driven by big waves of innovation. So if you go back in history, between the year 2000 and 2010, that was about computers coming up, PCs, laptop computers. The next decade, between 2010 and 2020, clearly characterized by the up-and-coming smartphones, tablets, and certainly cloud computing. And my vision, our vision at NXP, for the next 10 years is about the secure edge, the rise of the secure edge, the 50 billion devices in the middle of this period from 2020 to 2030, which are complementing the cloud computing centers in place already and making our lives so much easier. So this is all about applications in the smart home, connected cars, industrial automation, and all sorts of other smart connected devices. Now let me make this a little bit more specific relative to the competences required, the technology competences, and why do we believe as NXP that we have an unrivaled portfolio and position in terms of assets and market understanding to be the leader of this trend. We think it really takes 4 pillars from a technology perspective, which you need to be successful. It starts with sensing. Precision sensing and ranging is what most of these edge devices need. And to make it even more touchable, think about a smartwatch like this one here on my wrist. When I speak about precision sensing, it is about new functions like measuring the speed of my pulse, measuring oxygen levels. These are really elements which are new, and doctors are actually saying what these new smart devices are achieving is what medical equipment couldn't achieve in the past 20 years. So it's absolutely amazing what we make work here on the basis of our technology. Now the next step is the processing part. Artificial intelligence and machine learning are becoming major elements of the innovation advancement in that space. And NXP is very proud to have the broadest and best portfolio, scalable from very low levels all the way up to layerscape high-performance processors in that pillar. Then secure connectivity. Think about mobile payment. I don't have to have the coins anymore, the cash in my pockets. I just pay with the watch. But that goes again hand in hand with security. Because I want to be sure that my payments are at the same levels of security that I've been used to in the past from credit card payments. But it's also about data. I talked about health data, which is being measured, medical data, which is being measured and probably stored by my watch. I want to be sure that that very private data is secured. So the idea of security and safety is becoming paramount for the success of these solutions. And then last but not least, power management. There is no way anything of this works in a convenient way if we as an industry don't achieve the lowest levels of power consumption in all of the semiconductors which are included. And very practically speaking, this is simply down to the idea that I don't want to recharge my watch every 2 hours. All of that taken together has to be compounded, has to be surrounded by safety and security. Now, I promised you in the beginning of this keynote practical examples which we are excited about how that technology is at work today. Now, this smartwatch actually, which I'm very proud of, is the new Venue 2 from Garmin. And I think the best way to speak about that is that we listen to Phil from Garmin, who has actually worked successfully on the design together with NXP on this watch. So Phil, let us know how you think about what makes this watch so special.
Thank you, Kurt. Garmin really values its relationship with NXP. Our team set out to build a fitness-focused wearable with industry-leading battery life and a beautiful user experience. And we did just that with our recent launch of the Venue 2 smartwatch. NXP played an essential role in our efforts. NXP's i.MX RT500 crossover microcontroller provides amazing computational power and graphics with extreme low power modes, enabling the Venue 2 to offer double the battery life and a colorful and animation-rich overhaul of the user experience compared to the first-generation Venue. We've heard it said that low power is NXP's superpower, and all of us here at Garmin couldn't agree more.
Thank you so much, Phil, for sharing your insights with us. And by the way, I really have to admit it's always a pleasure to work with you guys at Garmin, especially when the outcome and the impact is such a beautiful product. I mean, I'm in the end proud to carry that. And I'm proud because I know it is powered by NXP. We are showing here the RT500 crossover processor, which delivers exactly on that promise which Phil was talking about, which is very, very enhanced levels of power consumption. And I can tell you from a practical use point perspective, it does make a difference when you do not have to always worry about the power level of your battery, and you can be sure the charge holds up. Just like Phil said, it's 2x of what used to be the levels in similar products earlier. We will take secure connectivity to the next level. And the way we do this is ultra-wideband. And based on ultra-wideband with our NXP Trimension portfolio. Now let's discuss this from the consumer's perspective. I talked earlier about the fantastic innovation of mobile payments, making cash and coins redundant. We follow the very same idea here to make mechanical keys, which we are all carrying with us, make these keys redundant and get that functionality of opening a door mechanically in a much more secure and a much more convenient way embedded into edge devices, be it phones or be it eventually watches. And this is an idea which NXP has been pioneering, and we've started to build a whole portfolio around it, a portfolio of products which are leading edge in terms of performance in spatial awareness and accuracy in real time, but also a portfolio of products which are enabling use cases, not only in the mobile space, but ranging across the IoT space, the secure intelligent edge, and automotive. NXP is building here on its deep and long-term experience of building ecosystems, as we've done in the past with secure NFC for mobile payment. And that's why I'm very proud today to give you two real-life examples of where we have brought that technology as of today. The first one is actually in automotive. We are at a point that in the second half of this year, several car companies will be launching cars which can be opened in a very secure and convenient way via your mobile device, based on NXP's ultra-wideband technology. Ultra-wideband technology is really set to become very, very handy for car owners everywhere. It promises both increased security and added ease when using car keys. Just take as an example BMW, as you can see here, which will use ultra-wideband technology in the new BMW iX to power BMW Digital Key Plus. And you can think about many new fantastic use cases, like sharing cars. I could actually send the authorization of using a certain car to my partner by email. So it would be much easier then that my partner picks up my car somewhere, even in the absence of a mechanical key. The other use case we would like to present you here is something we are proudly doing together with Samsung. We are proud that we have introduced ultra-wideband technology in the Samsung Galaxy Note 21 Plus. And earlier this year, Samsung launched the Galaxy Smart Tech Plus, which are a very smart idea to actually go find anything which you typically tend to lose very easy. One great example is actually a keyring. Many of us are just dropping the keyring somewhere and we don't find it again. Now, if you put one of these tags along the keyring, you can navigate and locate it very easily via your mobile phone. I think this is really a fantastic example of how the secure edge is going to make our life so much easier. Now, thanks again to the Samsung team for an innovation which I think really matters. You see that the high precision spatial awareness in real time of our ultra-wideband products really is impactful in a use case like finding again your keyring. So thanks again to the Samsung team for making this work together with NXP. Now at this stage, I move to our next topic. We have focused so far on high precision sensing as one of the technology vectors which is enabling the secure and smart edge. The next vector we want to focus on in this keynote is high efficient processing with advanced AI and ML algorithms. And who better could do this than our Executive Vice President and General Manager of our Secure Edge Processing business, Ron Martino. Ron, the floor is yours.
Thanks, Kurt. Welcome from Austin, Texas. I'm Ron Martino, Executive Vice President and General Manager of Edge Processing at NXP. These patents represent innovations we've made over the years that are leading us to a world that anticipates and automates. Everyone talks about AI, but understanding what it really means and its value in finding ways of solving problems is essential. There's so many opportunities, yet there are myths about AI, such as it's expensive to deploy, it requires massive processors, and it's too complex. But the truth is the opposite. AI doesn't always need large, complex, costly processors. And you don't need a PhD in mathematics if you have the right development tools. So how do we enable a world that anticipates and automates? With a foundation of edge computing that complements the cloud, Local edge processing reduces the cost of ownership and simplifies tasks that need to go to the cloud. Device makers should be able to choose an edge processor that's purpose-built for affordable artificial intelligence with high performance, low power processing, and built-in security. Keep in mind, there's no one-size chip that fits all. You shouldn't have to use an applications processor when a powerful crossover MCU can do the job at much lower system cost. On the other hand, there are many applications that need advanced machine learning response, and that's where processors with integrated acceleration fit the bill. The other critical foundation is software. It has to be easy to use, like our EIQ development environment. With its graphical user interface, it's designed to reduce complexity. Algorithms can be enabled across our MCUs and our processors, and it's flexible, where you can bring your own model or you can import a cloud-developed model. For those who want more turnkey, local voice and face recognition solutions can cut down development time. Pre-configured machine learning algorithms can be deployed on the device itself, inside a door lock, for example. It's all done on a single MCU, and it can recognize faces in the blink of an eye, and it cannot be spoofed with a photo. If you're like me and one of the 51% of consumers who purchased at least one smart device during the pandemic, you may have faced a few challenges when you wanted to add the device into your home. Devices from different manufacturers are aligned with different IoT ecosystems. Each ecosystem uses different standards, making it difficult for manufacturers and consumers to connect things together. Making a home smart shouldn't be a chore, and it shouldn't require a super user. What if every one of us could easily add intelligent devices into the smart home network so that these devices can interact and understand each other? That's the goal of Matter, previously known as Project CHIP. Matter is the unified IP-based connectivity protocol built on proven technologies that will run on existing networks like Thread and Wi-Fi. It's designed to simplify this interaction across smart home devices from different manufacturers. With interoperability, we'll be able to quickly add devices for a home that anticipates and automates. Lights. I can control them from my wearable or a smartphone. I can play music and it follows me throughout the house. But where we're heading, a truly smart home doesn't wait for my commands or presence to take action. The devices can learn and behave according to my preferences, and they can learn from each other. They can interact to determine the conditions of their surroundings. They can understand the context of the situation. Our homes can become occupancy aware. They can recognize when the house is empty and then automatically arm the security system, turn off the TV, lower the blinds, and adjust the lights in the HVAC. Now we're making the smart home a vibrant home. It's becoming a true digital zen. How do we transform our digital zen into a green digital zen? Each home can interact with other homes in the neighborhood or city to understand and balance the load. It's like going behind the scenes of the meter. Dishwashers can run and EV charging can be done at optimal times without stressing the grid. But there's one problem that we as a society need to address. Most of these devices are idle. This is wasted vampire power. You may be shocked to hear that 1 year of wasted vampire power across the US can power the entire New York City with all its skyscrapers for 3 full years. What a monumental waste of energy. Energy efficiency and intelligence must be designed into everything, starting with the chips. This is where NXP differentiates. Our Energy Flex architecture provides a wide range of power options that are customizable for end applications. With this, we can eliminate more than 90% of the energy waste. So how do we apply this same cost-effective AI edge technology to factory automation. With Industry 4.0, we're seeing a fast transition into productive and safe cyber-connected factories. People work alongside robots and smart equipment. Connected robots can make intelligent decisions based on the context of the entire factory floor. Data is used for automation, efficiency, and safety. To reach this new era of manufacturing, key foundational technologies are needed. We already spoke about one of the enablers, machine learning. All of that applies equally to Industry 4.0. Another key enabler is predictable connectivity between machines. Enter time-sensitive networking, or TSN. Using NXP processors and microcontrollers that integrate gigabit Ethernet with TSN, you can dedicate and prioritize data streams from any machine to every machine. For example, data from the CNC milling machine to a robotic arm can be prioritized for real-time delivery. Meanwhile, another machine can be sending lower priority data to the predictive maintenance system. When machines collaborate intelligently at the edge, we can experience far greater situational awareness, a factory floor that anticipates and automates. This leads to higher levels of efficiency and productivity and a safer work environment. You can use AI vision edge processing for flexible virtual safe zones. Without moving fences, you can shut down or slow down the equipment if an operator gets too close to an area or a machine where it's potentially unsafe. The edge process data can be securely shared with a digital twin in the cloud for further analysis of the entire manufacturing setup. Another connectivity capability is UWB. Like Kurt mentioned earlier, couple it with face recognition on our i.MX processors, and you have two-factor authentication, and it's all hands-free. NXP's expanded AI ecosystem includes the world's leading providers of cloud services, development tools, and board solution makers. My next guest is an ecosystem partner focused on bringing AI to the edge. Let's hear from Miller Chang, President, Embedded IoT Group at Advantech.
Advantech is devoted to the mission of enabling an intelligent planet by co-creating the IoT solutions with business partners and ecosystem. We realize there's no one can drive AIoT development alone. Partnering with NXP, Advantech accompany our client to walk through the challenge of the new embedded technology and business deployment. Leveraging NXP's latest AI-native i.MX AM Plus processor with NXP EIQ machine learning development toolkit, Advantech can offer a full range of embedded products and services, help achieving your goal in smart factory application.
Thank you, Miller, for sharing your perspective. For a society that desires to protect personal data and critical business information, securing our edge devices from unauthorized access is a basic necessity. We must be able to trust our devices. But how do you address hackers, especially when bad players are getting more technologically sophisticated day by day? How do you keep one step ahead? At NXP, we believe strongly in building products from the ground up with a security by design approach. Our new EdgeLock Secure Enclave is integrated into our latest processors. It's pre-configured to help ease the complexity of implementing robust, system-wide and intelligent security. How do you keep an edge device secure long after it's in the field? It requires nonstop trusted management services. That's why we partnered with Microsoft. Let's hear from Roanne Sones, Microsoft's Corporate Vice President of Azure Edge and Platform.
I'm excited about the deepening edge partnership between NXP and Microsoft and what this will enable you, our mutual device builders, to create. We are combining NXP's expertise in silicon with Microsoft's expertise in software and cloud to create a whole new class of secured SOCs for the IoT market. The IMX8 ULPCS with Azure Sphere integrates flexibility with security to offer a fast track for your innovation. Whether you are creating secured industrial equipment, infrastructure, home appliances, personal devices, it's all possible with this SOC. This SOC is really the first of its kind. It's designed with Microsoft Pluton on EdgeLock Secure Enclave, delivering a hardware root of trust at the silicon level. It also includes a Microsoft OS with over 10 years of continual updates to protect and defend your devices against ongoing attacks. We obsess over security so you don't have to. Together, we can give customers flexibility and control over their IoT environment and the peace of mind that when it comes to security, Microsoft, NXP, and you have their backs.
Thank you, Roanne. We busted the myths about artificial intelligence. It's accessible. It's not expensive. You can run it on affordable edge processors and simplify development with easy-to-use tools. As our devices become more intelligent and can share insights with each other to make decisions, these systems will achieve a level of contextual awareness for a world that truly anticipates and automates. But most importantly, these systems must be built on a foundation of uncompromised security. For this new era of the intelligent edge, the NXP team and I are committed to bring to the market cost-effective, secure edge processing solutions which perform meaningful tasks independent of human interaction, but consistent with human desire. We're now going to talk about automotive, and it's my pleasure to introduce Shelly Van Dyke, our Vice President of Strategy for Automotive Processing.
I'd like to talk about a foundational element in automotive, trust. We want to trust our cars because many of us depend on our cars to get us where we want to go, to keep us safe along the way, and to keep our information secure. Security is foundational to building that trust. NXP has a great heritage in security from the first immobilizer in 1990. And now today, we have a variety of security capabilities from a hardware secure element to secure networking and new levels of security for accessing your cars thanks to ultra-wideband. But security is just one aspect that adds complexity to the car of the future. There's more. The car is the most complex edge device in the world. I think of it as a factory on wheels. It has to coordinate across many machines and deliver the right actuation at the right time, such as to stop at a red light, accelerate at a green light. Further complexity comes from stringent safety requirements, software complexity. Already we're at 100 to 200 million lines of code, more than a spaceship. And while we've heard that an autonomous car will generate 4 terabytes of data an hour, that could be far into the future. But even today's cars generate about 50 gigabytes of data a day, and they need to transfer 1 to 2 gigabytes with all the sensor data and other information that the electronic systems generate. For all of the computing in the car, there are about 50 to 100 electronic control units in a modern car. And on top of that, there are ever more and better sensors being added that enhance safety and information. The networking infrastructure, or the nervous system, has increasing challenges. Physically, the wiring harness weighs over 75 kilograms in an average car today, with the wiring length 1 to 2 kilometers, 100 plus connections to be made. We are ideally positioned through our heritage in automotive and in security, through which we have built many technology leadership positions and application leadership positions. While high compute power is important, automakers expect us to deliver more: safe and secure, robust and high quality, efficient, scalable across their entire fleet, not just for one car model in their lineup. Let me walk through an example that involves 2 of our flagship processors. NXP Green Driving delivers powertrain domain control across all types of electric vehicles for efficient and safe vehicle propulsion using our high-performance real-time SoC, the S32S, and the Greenbox development platform. NXP Connected Driving delivers the service-oriented gateway using our vehicle network processor, the S32G, in our Gold Box. This enables vehicle-wide secure connectivity and cloud connectivity. Secure cloud connectivity brings the power of the data center to the vehicle edge and helps OEMs unlock the value of vehicle data to enable new use cases. Our green box processes in-vehicle data. Our battery management system precisely monitors the battery status. Input for the green box are precision battery management system data plus data from traction motors. In parallel, the gateway, based on the gold box here, receives data from the cloud including weather, traffic density, road gradient. The goal is to improve range precision. The cloud data are transferred to the green box to optimize the calculation of the battery range. The cloud data are enhanced input to the power management system algorithms. This is AI/ML applied in a very focused way for system optimization, suitable for the specific road, place, and weather that the driver is experiencing. This clearly proves the complementary power of edge computing and the cloud. To meet the challenges that customers are having with centralized access to vehicle-wide data that can work securely and collaboratively with the cloud, we knew that we needed partners, and I'm very excited about our strategic partnership with Amazon Web Services. Let's hear more about this from Bill Vass at AWS.
Hi, my name is Bill Vass. I'm VP Technology at AWS Web Services. Our team runs about 80 different services that include connected car, IoT, edge processing, streaming, and a whole host of other services. We're very excited to be working with NXP on their S32G vehicle network processor and the ability to run Greengrass locally in the car, which extends the cloud to the car and cloud processing in the car, along with SageMaker, so local machine learning models can be executed and created to really advance the capability of what can be done on the edge in the car. As vehicle manufacturers move to software-defined connected vehicles that are electrified, it really allows you to extend advanced cloud capabilities into the car. The work we do together will really help vehicle manufacturers adopt this technology and make it seamless and easy for them to integrate and expand, do over-the-air updates, and continue to advance the capabilities of their cars throughout the life cycle of the automobile.
Thank you, Bill, and thanks to the AWS team. Together, we have great potential for unlocking services and capabilities not even thought of today, all based on intelligently combining cloud and in-vehicle data. The key domain in the car that is going to deliver this capability is the gateway. Let's unbox that and take a look at the S32G vehicle network processor at the core of the gateway. S32G is a new type of automotive processor built on a new platform for automotive. All of our S32 products have the capability to support the highest levels of functional safety, security, over-the-air updates, and a software platform that spans from our MCUs to the processors. The S32G has dedicated accelerators for networking functions, which optimize performance and free up the main CPU cores for our customers' applications, such as those cloud services we just talked about. The S32G has a development platform called the Gold Box, which has a lot of flexibility for customers, such as 4-key automotive networking interfaces and expansion for memory or AI/ML. The S32G is just one of the products in our complete family of S32 processors for every domain in the vehicle. Radar for safe driving, the S for safe electric vehicles, and the S32Ks are MCUs for many end nodes throughout the car. These products have common peripherals and software infrastructure for customers to optimize the reuse of software and hardware. And I'm very proud to announce today that our two flagship processors, the S32R and the S32G, have made the next leap in optimizing size, power efficiency, and performance. They are ready for mass production in 16-nanometer FinFET technology. This is from our key manufacturing partner, TSMC. NXP brings security, enterprise-level networking, safety, and quality from our decades of automotive experience, and this builds on TSMC's leading manufacturing technologies. What we are announcing today is the release into volume production of NXP's S32G2 vehicle network processor and S32R294 radar processor. Both are on TSMC's advanced 16-nanometer FinFET process technology. We are working on migrating our S32 platform processors to increasingly advanced process nodes. This is relevant as automobiles continue to evolve into powerful computing platforms. NXP's continued innovation in the S32 family is designed to help car makers simplify the evolution of the vehicle architecture and deliver the fully connected and configurable car of tomorrow. Thank you to TSMC for their partnership in reaching this important step. The S32R and S32G processors are part of NXP's strategy of offering a scalable S32 core architecture. They have harmonized software infrastructure, safety and security concepts, and common peripherals that work across vehicle domains. Plus, accelerators enhance performance in key applications. This can greatly reduce time to market and system cost. So in summary, yes, the car is the most complex edge device. With safe, secure, and intelligent processing, we can help our customers greatly reduce that complexity, accelerating the time to market and reducing system cost. That's our mission here at NXP. With that, I'll hand back to Kurt.
Thank you so much, Shelly, for what I felt was a very insightful journey into how the future transformation of the architecture of the electronic system in the car looks like and what leading role NXP is going to play in that transformation. 2021 is only marking the beginning of that edge era going forward. And it is going to be a long, a challenging, but also a very, very rewarding era. NXP is going to be everywhere. Our end markets, from automotive to industrial IoT, mobile, and communication infrastructure, they match the growth applications for secure and smart edge devices. We do have the R&D muscle, we do have the product portfolio to be the relevant leader in that development. Now at this point, I want to thank you all very much for your attention. I hope we could give you some inspiring thoughts about what is ahead of all of us. And I wish you a fantastic and insightful time here at Computex. Thank you very much.